In our modern age, we are surrounded by amazing technology. We look to smart devices, advanced materials, and computer systems to fix almost every problem. When we think about staying alive in a tough situation, our minds often picture fancy high-tech bunkers. These are the shiny metal shelters you see in movies with satellite connections and computer-controlled life support. But right under our feet, buried in history, is a better design. The Cold War-era fallout shelter, often seen as just an old thing from the past, is actually a great example of smart engineering. Its strength wasn't in fancy electronics or new features. It was in how simple it was and how well it understood human weaknesses and problems with the environment. These shelters were made during a time of huge military spending and big steps forward in technology. The same time gave us nuclear power, space travel, and the microchip. But the engineers whose job it was to protect people from nuclear fallout looked past the shiny new technology. They understood a basic truth that we sometimes forget today. Complicated things can cause problems. When the world outside is crazy, the last thing you want is a system that needs a special expert to fix it. The cleverness of these shelters was that they used old, proven ideas. They used the Earth itself as their main shield and used natural physics to make a place where people could live. This shows they thought ahead instead of just following trends. Today, we can walk through some of these saved structures, like the once secret Hack Green nuclear bunker in Cheshire. Standing inside its thick concrete and earth-covered walls, you really get a strong feeling of why it was built. It wasn't made to be comfy or fancy. It was made to last. The main idea behind the design was clear: make a strong fort that could work without outside power, without new supplies, and without needing constant tricky repairs. This way of thinking is very different from many modern bunkers, which often have systems so complex they can easily break down. The old way was about being strong and able to bounce back, not about relying on gadgets that might fail when you need them most. This essay will look into the forgotten smart ideas of these Cold War forts. We will explore why their builders purposely chose simple, passive solutions instead of the complicated machines of their time. We will look at the amazing benefits of using earth mounds, the smart design of having many rooms, and the simple science that kept them safe and livable. By looking back, we can find timeless lessons in engineering, taking care of ourselves, and staying alive. These ideas are just as important for builders, historians, and people who prepare for emergencies today as they were during the tense years of the superpower standoff. The past, it turns out, has a lot to teach us about getting ready for a future we're not sure about. The engineers of the Cold War were not against new technology. They were at the front of a technology revolution, working in a time that saw the start of computers and atomic energy. However, when it came to designing shelters for the worst possible disaster, they were very careful and a bit doubtful about complex technology. They understood that the very event these shelters were built to survive, a nuclear war, would likely break down the advanced systems we now take for granted. An electromagnetic pulse, or EMP, from a high-up nuclear explosion could instantly burn out sensitive electronics, making modern computer-controlled systems useless. The designers knew that a shelter that relied on a computer brain would become a tomb the moment its circuits were fried. This idea came from tough experiences on the battlefield. Military history is full of stories where fancy weapons failed in the mud and mess of fighting. Soldiers have always known that the simplest, strongest tools are the ones you can count on. The engineers used this same logic for protecting civilians. They asked a very important question: what will still work after the worst has happened? The answer wasn't a delicate computer chip or a sensitive electronic sensor. It was gravity, air pressure, and the huge protective mass of the Earth itself. Their designs were therefore based on what we now call passive survivability, meaning a building's ability to keep people alive without needing active, powered systems. Think about the other option. A modern bunker might have a fancy computer-controlled air filter system. It promises to work perfectly, with sensors always adjusting how much air flows and how clean it is. But what happens when the power goes out, the backup generator runs out of fuel, or a single circuit board breaks? The whole system could shut down, leaving the people inside with less and less breathable air. The Cold War designers saw this exact problem coming. Their solution wasn't to build a better computer, but to design a system that didn't need one. This purposeful avoidance of relying on technology was their biggest strength, making sure the shelter stayed a safe place, not a high-tech coffin. This way of thinking is very different from how we do things now. We are used to looking for technology to fix every problem. Our cars, homes and workplaces are full of gadgets made for comfort and efficiency. But in a real survival situation, these comforts become weak points. The Cold War shelter was the opposite of this. It was a machine with very few moving parts, a fort built on the strong rules of physics rather than the unreliable nature of electronics. This natural distrust of gadgets wasn't a sign of being behind the times. It was a sign of being far ahead in understanding what true strength means. One of the most important features of Cold War shelters was the smart use of earth berming. This is when you pile large amounts of soil against the walls and over the roof of a building. It might sound simple, but it's an incredibly effective solution that does many things. Its main benefit, of course, was protecting against radiation. If a nuclear bomb went off, deadly gamma rays would fill the air. Materials like concrete and lead are good at blocking this radiation, but they are expensive and have limits. The engineers knew that a lot of mass was the most effective shield of all. A thick layer of tightly packed earth provides excellent protection, soaking up radiation much more cheaply and effectively than a design that only uses concrete. The benefits of earth berming go far beyond radiation. The huge weight of the soil makes the structure incredibly strong and stable. A shelter with earth berms is naturally protected from the blast wave of a nearby explosion. The earth acts like a giant shock absorber, spreading out the huge pressure and ground shakes that would otherwise break a stiff, exposed building. This makes the shelter much stronger against the physical impact of an explosion. Also, the soil provides a strong barrier against regular weapons and the chaos that might happen in a world after a disaster. It turns the shelter from a simple concrete box into a strong bunker, built smoothly and secretly into the landscape. Another benefit that people often don't notice is how it keeps the temperature steady. Earth is a fantastic natural insulator. A shelter buried under several feet of soil stays at a very stable temperature inside all year round. It stays cool in the summer and relatively warm in the winter, greatly reducing the energy needed to heat or cool it. In a long-term survival situation where fuel is hard to find, this natural temperature control isn't a luxury. It's a crucial feature for staying alive. A bunker made only of concrete exposed to the weather would have big temperature changes, needing a constant and lot of energy to stay livable. The earth-bermed design solves this problem for free, using nature itself to control the climate. Finally, the earth covering makes it incredibly hard to see. A properly bermed shelter with plants growing on it can be almost invisible, blending into a hillside or disappearing under a field. In a world where resources are scarce and people are desperate, being unseen is a powerful form of safety. Modern bunkers are often obvious buildings, making them easy targets. The low-profile, earth-integrated design of the classic shelter offered a smart advantage. It was a fort hidden in plain sight. By using the earth as armour, insulation and camouflage, Cold War engineers created a shelter that was stronger, more stable and more sustainable than any exposed modern equivalent. The inside design of these Cold War shelters was just as smart as how they were built on the outside. Instead of making one big open space, designers split the inside into a series of separate rooms. This multi-chamber design wasn't just a random choice, it was a brilliant solution to several really important survival problems. The main reason was to control contamination. Imagine people coming into the shelter from a world full of radioactive fallout. A single-room bunker would instantly get contaminated. The multi-chamber system created a vital airlock. The room furthest outside acted as a cleaning zone where people could take off dirty outer clothes and gear before going deeper into the protected areas of the shelter. This separation into different sections was also key for managing the inside environment. Different rooms could be used for specific things, which helped control air quality, how much moisture was in the air, and even stress. One room might be for living and sleeping, another for storing food, and a third for toilets and washing. This separation was essential. For example, keeping the toilet facilities in a separate, well-aired room stopped bad smells and germs from spreading into the living areas. Likewise, storing food in a special cool, dry room helped keep it fresh for longer. This division of space brought order and cleanliness to a small, stressful environment, which was very important for living there for a long time. Also, the multi-chamber layout provided an important layer of internal protection. If one part of the shelter were to be damaged, maybe by a small break, a fire, or a sickness outbreak, the problem could be kept from spreading. Heavy, sealable doors between the rooms meant that one problem didn't have to become a disaster for everyone. A damaged room could be sealed off, protecting the rest of the shelter and the lives of the people inside. This idea of having backup systems and containing problems is a basic part of good engineering design. A modern, open-plan fancy bunker doesn't have this internal strength, making it much more likely to fail from one single problem inside its walls. This design also had good effects on people's minds. Living in one single crowded room for weeks or months would be very hard mentally. Being able to move between different zones, even small ones, gave a sense of order and normalcy. It broke up the boredom and gave people a feeling of having separate spaces for different activities, just like they would in a normal house. This seemingly small detail could make a huge difference in keeping spirits up and mental health good during a long crisis. The multi-chamber design was a masterclass in engineering that focused on people, solving practical problems of contamination and cleanliness, while also taking care of the psychological needs of the people it was built to protect. Perhaps the smartest part of engineering inside these shelters was their passive ventilation system. Making sure there's a constant supply of fresh, breathable air is the single most important challenge for any sealed space. Modern bunkers solve this with electric fans, complex filter units, and air scrubbers that use a lot of power. But the Cold War designers, always careful about systems that could break down, turned to basic science. They created a system that could run forever without electricity, moving parts, or repairs. This was done by designing it to use natural air pressure and heat movement, a principle called the chimney effect or stack effect. It was simple, reliable, and incredibly smart in how it worked. The system worked by having two separate air pipes placed at different heights. An intake pipe would be low to the ground, often hidden in bushes or behind a wall, to pull in outside air. A much taller exhaust pipe or chimney would rise high above the shelter. The air inside the shelter, warmed by body heat and activities like cooking, would naturally become lighter and rise. This warmer, lighter air would flow up and out of the tall exhaust chimney. As the air left, it would create a slight lower pressure inside the shelter. This pressure difference would then pull cooler, heavier, fresh air from the outside in through the lower intake pipe, creating a continuous, gentle cycle of airflow. This passive system was incredibly strong. It didn't need fans, motors, or electricity. As long as there was a temperature difference between the inside and outside of the shelter, a difference guaranteed by people being inside, the air would keep moving. To protect against fallout, the intake pipes had simple but effective filters and were designed with sharp bends. Heavy radioactive particles, not being able to easily change direction, would settle in these traps instead of being pulled into the living space. This simple filtration, combined with the constant airflow, made sure the air stayed both breathable and safe, all without using any power. This way of dealing with pressure balance and air movement is completely opposite to modern high-tech solutions. An active powered system is not only likely to fail from EMP and power outages, but also needs a stock of spare parts and someone skilled to install them. The passive system of a Cold War shelter, on the other hand, takes care of itself and needs no repairs. It cannot break down. It simply works, driven by the basic rules of how heat moves. This elegant simplicity is the sign of true strength. It proves that the strongest solutions are often not the most complex, but rather those that work with nature instead of fighting against it. When we compare the classic Cold War shelter to its modern high-tech version, the answer is clear. The expensive digital bunkers of today, which rely on delicate electronics and complex systems, have basic flaws. They are built on the idea that things will stay stable, that power will be available, that spare parts can be found, and that nothing will go terribly wrong with the technology itself. This is a dangerous idea. The Earth-Bermed multi-chamber fallout shelter was built on the opposite idea, that everything that can fail will fail. This way of designing for failure is exactly what makes it the better and stronger model for survival. Its strength is its simplicity. The older design is better for a few key reasons. It uses the huge, free and reliable mass of the Earth for protection, stability and insulation. It divides its space to control contamination, manage the environment and provide backup systems inside. And most importantly, it relies on passive science-based systems for life support, making sure it can work forever without outside power or complex repairs. These are not old-fashioned ideas. They are timeless principles of strong engineering. A modern bunker is a delicate system tied to technology, while a Cold War shelter is a self-sufficient fort based on the laws of nature. It's like the difference between a smartphone and a hammer. One is an amazing complex thing. The other is a tool that will always work. For modern preppers, survivalists, and even engineers, the lessons are deep. Chasing the newest gadget can create a dangerous false sense of safety. True preparedness isn't about getting the most advanced technology. It's about building strong, simple, and reliable systems. Anyone thinking about building a shelter today would be smart to study the plans from the past. Using earth berming, passive ventilation, and separate rooms will create a safe place that is not only cheaper, but also much more likely to keep people alive than a shiny concrete box full of computers. The goal should be to not rely on complex supply chains and fragile power grids, not to become more dependent on them. In the end, the history of these Cold War shelters is more than just a curious part of military history. It's a masterclass in practical problem-solving and understanding risks. The engineers of that time, facing the huge threat of nuclear war, didn't back down. They looked past the temporary appeal of new technology and put their trust in the lasting power of earth, air, and smart design. They understood that in the most important moments, the simplest solutions are the ones that save lives. Their forgotten forts remain a silent, buried reminder of that wisdom, offering a vital lesson that true safety is built not on being complex, but on lasting strength.